Assalamualaikum and salam sejahtera. Welcome to the basic guide of Consolidated Drain Triaxial Testing module. For CU testing, the cell pressure valve is open in order to fill up the triaxial cell with water from the de-air water tank system. The bleed valve remains open or loose during the process of filling up the triaxial cell. Please ensure the whole cell is fully filled up with water. For CU testing, the cell pressure valve is open in order to fill up the triaxial cell with the water from the de-air water tank system. The bleed valve remains open or loose during the process of filling up the triaxial cell. Please ensure the whole cell is fully filled up with water. Close and tighten the bleed valve after the cell is fully filled up with water. And then close the cell pressure valve. Disconnect the tubing from the water tank. Connect the tubing from the pressure controller to the triaxial cell via the cell pressure valve. The back pressure controller is always connected to the triaxial cell via the back pressure valve. Open the pore water pressure valve, which connects to the triaxial cell. Make sure that the pressure controller has been filled up with water. Connect the tubing from the pressure controller to the triaxial cell via the cell pressure valve. For the back pressure controller, make sure that the pressure controller has been filled up with water, 2/3 of the capacity. Connect the tubing from the pressure controller to the triaxial cell via the back pressure valve. Saturation stage is the process to remove air voids inside the soil specimen. For the cell pressure controller, set the pressure to 50 kPa. Observe the increment of the cell pressure until it reaches the 50 kPa mark. Once it reaches the desired pressure, observe the pore water pressure reading. At the same time, set the pressure to 40 kPa. Observe the increment of the back pressure until it reaches 40 kPa. The cell pressure and the back pressure will be maintained subjected to the condition where there will be no more increment to the pore water pressure. Observe the pore water pressure reading until it is stabilized with no further increments. Follow the incremental intervals of the cell pressure and back pressure given here until the cell pressure increased to 350 kPa and the back pressure increased to 340 kPa. Then we can go to the next stage, which is the B-check. B-check, cell pressure and back pressure guide. Consolidation, cell pressure and back pressure guide. In addition, we can also check the reading sensitivity of the load cell reading by adjusting the stage either up or down. Make sure that the LVDT is free to move up and down and give a positive and negative reading when it is pushed up or released. That means the LVDT is ready to be used. Recheck when both load cell and LVDT are ready, then both reading can be set to 0. Set the loading rate to 0.02 mm per minute. It is a consolidated drain testing where the shearing speed is maintained at a very slow speed in order to eliminate sudden increase in the pore pressure. For a 38 mm diameter soil specimen, to reach the yield point for the soil to fill, which is 20% of strain, may take up to 760 minutes. For a 50 mm diameter soil specimen, to reach the yield point for the soil to fill, which is 20% of strain, may take up to 1000 minutes. Do take note that the soil could reach the yield point before reaching the 20% strain mark. During testing, the stage moves up at the rate of 0.02 mm per minute and thus compresses the soil specimen. Stop testing once the soil sample has reached its failure point. The dashed red line showed the original soil sample condition. Reverse the stage so that it returns to the original position. Set the cell pressure and back pressure to 0 kPa. Then close the back pressure valve and the cell pressure valve. Disconnect the tubing from the pressure controller. By using another tube, connect it to the cell pressure valve. This is to channel the water out from the triaxial cell. Open the bleed valve so that the atmospheric pressure helps to drain out the water from the triaxial cell. Also open up the valve for the cell pressure. Water can now flow out from the triaxial cell. Once the cell is completely drained, carefully dismantle the cell and carefully remove the soil from the rubber membrane. For CD effective stress of 100 kPa and 200 kPa, the second and third soil specimen will undergo the same routine as described earlier on. The only difference will be the consolidation stage due to the different effective stress value. Refer to this pressure guide for the consolidation stage for the effective stress 100 and 200 kPa. We can obtain the following data from the test. We can also plot the Mohr circle graph for the total stress test. And we can also plot the Mohr circle graph for the effective stress test. We can generate the volume change graph. We have come to the end of the basic guide of consolidated drain triaxial testing module. Thank you very much for watching. Till we meet again, wassalam and salam hormat.